Hello all, welcome back to Electronic Devices and Circuits video lecture series. I am BVV Sachinarayana, Associate Professor in Department of ECE, Vishnu Institute of Technology, Bhimavaram. Unit number 3 of EDC is rectifiers and filters. And in last two videos, we discussed about introduction and basic rectifiers setup. Now in this video, I'm trying to give some brief details about half-wave rectifier circuit. Half-wave rectifier circuit. The objectives of this lecture are the circuit diagram of half-wave rectifier, operation of half-wave rectifier, and waveforms of half-wave rectifier. Half-wave rectifier circuit basically consists of a rectifying element called PN junction diode, a AC voltage source, step-down transformer, resistive load, and all these are connected in series. And in half-wave rectifier circuit, only one diode is used, and this diode conducts during positive off cycle of input AC source, and during negative off cycle it doesn't conduct. So the negative off cycles are completely eliminated from the output. Only positive off cycles are appears in the output. So we can say for full input cycle there is only off cycle conduction, and hence this rectifier is called half-wave rectifier. The circuit diagram of this half-wave rectifier is given below. This is the circuit diagram of half-wave rectifier. I already told this half-wave rectifier consists of AC source that is 230 volts, 50 Hertz AC mains. And this 230 volts 50 Hertz AC main supply is given to a step-down transformer. I already told in electronics we need a very small DC voltage. That's why this 230 volts 50 Hertz signal must be reduced to the required DC level. For that we are using a step-down transformer. Okay. The number of turns on the primary we are calling it as N1, and the number of turns on the secondary we are calling it as N2. And for the step-down transformer, no doubt that N1 is greater than N2. So because of this less number of turns on the secondary, the AC input signal is reduced to our required DC level. And that secondary voltage is applied to the rectifying element, that is diode. This half-wave rectifier, it consists of only one diode. Then the output of the diode is directly given to the resistive load. Here in the transformer secondary, the upper terminal, the transformer secondary upper terminal, we are representing it as A, and lower terminal we are representing it as a B. The upper terminal A is connected to anode of the diode, and the lower terminal is connected to the cathode of the diode. So that is the circuit diagram. So in this, the turns ratio of this step-down transformer is N2 by N1, which is equal to VSM by VPM, where that VSM is the secondary voltage, peak value of secondary voltage, and VPM is the peak value of primary voltage. So this N2 by N1 is equal to VSM by VSP, that is the turns ratio of the transformer which is used in this half-wave rectifier circuit. Then I move to the operation of half-wave rectifier. So for half-wave rectifier, we are applying a AC signal, and that AC signal, which consists of a positive half cycle and a negative half cycle. So I'm trying to explain the operation of this half-wave rectifier during positive half cycle and negative half cycle. So first I am trying to explain the operation of this rectifier circuit during positive half cycle. During positive half cycle of AC input. During positive half cycle of the AC input, the upper terminal A is positive with respect to the lower terminal. I am considering only the positive half cycle of the input. During this, upper terminal A is positive and lower terminal B is negative. So anode is connected to positive terminal and cathode is connected to negative terminal, and this diode is said to be operated in forward biased, and it offers some resistance. That resistance we can represent it as a RF. Since the diode is forward biased and all these are connected in series, some current is flowing through the circuit, and the same current is also flowing through the load. That's why that current I am representing it as IL. So ideally, almost there is negligible drop across the diode, and hence all the input voltage is dropped across the load. So the complete positive half cycle is reproduced across the load. For full positive half cycle, the diode it is in forward biased and we are getting the load current. And the second one, during the negative half cycle of the input. During the negative half cycle of the input, AC input. Now we are considering the negative half cycle. Positive half cycle already completed, and I'm considering this negative half cycle. During this negative half cycle, terminal A is negative with respect to terminal B. Means anode terminal of the diode is connected to negative, cathode terminal is connected to positive. So this diode D is reverse biased, and hence it offers a very large resistance. Ideally, open circuit means almost the RR resistance it is equal to infinite almost ideally, and the diode it simply act as a open circuit, and hence no current is flowing through the circuit. Since all these are in series, the load current is equal to 0. Means the output voltage VDC or EDC is equal to 0. No negative half cycle is reproduced. Negative half cycle is reproduced at the output. So for full cycle, if you consider, there is only half cycle conduction in the load. That's why this particular rectifier we can call it as a half-wave rectifier. That is the operation of half-wave rectifier. Then I move to the waveforms of half-wave rectifier. So you can draw various waveforms for this half-wave rectifier. So the first one is AC input signal, and second one is load current, third one load voltage, and fourth one voltage across the diode. Voltage across the diode. I'm trying to sketch these 4 waveforms. and all these are the waveforms. So there are 4 waveforms in this diagram. First one, AC input signal, load current, load voltage, and voltage drop across the diode. Okay. First, I am trying to sketch input voltage, input AC voltage. So this is the reference line for AC input voltage, and AC input is a bidirectional signal which consists of both positive and negative. So I'm starting here. So this is positive half cycle of the input, and this is negative half cycle of the input. That is the input signal. Okay. Since it's a sinusoidal signal, we can assuming it as a ES or VS equal to Vm sin omega t. That is a sinusoidal signal. Now I am trying to obtain the load current from the sinusoidal signal. During the positive half cycle of this input, diode D is forward biased, and the positive half cycle is completely reproduced at the load. Whereas during the negative half cycle of the input, diode is reverse biased and load current is equal to 0. So for full cycle, there is a off conduction. That's why it's a off wave rectifier. Again, we are getting a positive half cycle and it is completely reproduced at the output. And negative half cycle, output equal to 0. Positive half cycle, again it is completely reproduced. Okay, that is the waveform. And coming to load voltage is proportional to load current. So V naught equal to IL into RL. So load voltage is proportional to the load current, and hence positive half cycle is reproduced, negative half cycle current is 0, positive half cycle reproduced, negative half cycle current is equal to 0. So load voltage and load current both are proportional. Now, what is the voltage drop across the diode? If the diode is forward biased, it can act as a short circuit, and short circuit across voltage equal to 0. That's why during positive half cycle, diode is forward biased, diode act as a short circuit across voltage equal to 0. Means all the input voltage it is dropped across the load, no voltage or negligible voltage is dropped across the diode. And during negative half cycle, diode is reverse biased, no load current, no voltage drop across the load, and hence all the voltage is dropped across the diode only. Then again during positive half cycle, diode is forward biased, it acts as a short circuit, and ideally the voltage is 0 across the diode. And during negative half cycle, diode is reverse biased, it acts as a open circuit, so that we are getting a maximum voltage across the diode. And I already told the maximum voltage across the diode is called peak inverse voltage. So the maximum voltage across the diode in reverse bias. Here it is the maximum voltage. So that we can treat it as a Vm. Vm is the peak inverse voltage of half-wave rectifier, which is the voltage drop across the diode during positive half cycle. So these are the waveforms of half-wave rectifier. If you clearly observe these waveforms, the input is bidirectional, whereas the output is unidirectional. Okay, so this particular half-wave rectifier, it converts bidirectional signal into unidirectional signal. So from the rectifier, we are expecting a perfect DC, but it is not perfect DC. The output of the rectifier, it consists of positive sinusoidal pulses. So there is some AC component. That's why the output of the rectifier, we can call it as a pulsating DC. It's a pulsating DC, not perfect DC. The output of the rectifier is the pulsating DC. It is not perfect. There is much AC component present in the output of the rectifier. Then coming to the summary, in this lecture we have learned the following: circuit diagram of half-wave rectifier, operation of half-wave rectifier, various waveforms of half-wave rectifier. In the next video, we will discuss about the operation waveforms of shunt tapped full wave rectifier. Thank you all.